Hey guys, so this is probably our last instructional video, so that'll be good. It'll be good to be teaching you guys in person again for sure, because we've just got some complicated stuff going on. So we are jumping into Module 4 today, and we're talking about molecular structure. So we've been talking about, the electron configuration with all our different orbitals and their shapes and energy levels, and I know it all seems like very esoteric, the word they use, just sort of like just for the sake of knowledge. And it kind of is for some of us, just, unless we're becoming chemists, but you never know. There's a lot of jobs that involve chemistry. So don't kind of rule yourself out from that. You may, and you maybe won't be dealing this on a regular basis, but you might need the chemistry to get to where you want to be or what you want to do. Like for instance, a nutritionist, I didn't realize, at least at our school, they took a lot of biochemistry. So they took regular chemistry, organic chemistry, and then biochemistry. Lots of really cool stuff. So I'm sure they don't use that in their everyday when they're doing nutrition, but they needed it for the degree. So anyway, that's a little bit of a rabbit trail. So we are going to be talking about electron configuration in the periodic table and what we can learn about elements from their electron configuration. Because basically, we're going to be looking at the electrons that are the farthest away. Because the electrons that are the farthest away are the ones that determine the chemical behavior of that element. And then those tend to follow patterns on the chart. And we actually give those electrons a name, the ones that are farthest away, and they're called valence electrons. They have the highest energy level number. So remember we had that 1s2, 2s2, so we went from 1, 2, 3, 4, 5. That was the energy level. So let's look at some specific examples here, or look at a specific example. Let me write this on here. A pen that was a little bit darker. Where did it go? I guess I'll just use this pink. I think it's pretty dark. I'm going to need some new pens here pretty soon. So I'm going to write out quickly instead of just figuring it out with the chart. The electron configuration for fluorine. So it goes 1s2. You can kind of follow along on your chart and see if you get what is here. 2s2 and then 2p5. And then I'm going to do chlorine, which is in the same column, right? Chlorine, yeah. We're going to do chlorine. So that goes from 1s2 to 2s2, 2p6, 3s2, 3p5. And then we're also going to look at iodine, which gives us 1s2, 2s2. You're going to be saying these in your sleep, right? You'll be mumbling them as you go along the way. 3s2, 3p6, 4s2, 4p6, 5s2. So I just already had these written down from the book in case you're like, well, where's she getting these? I mean, you could get them from the chart, but I'm not just pulling this out of my head is what I mean. I wouldn't just know that off the top of my head. I would have to use the chart. So if we look at all these, we are going to try to figure out how many valence electrons are in each of these. So we're counting the electrons in the highest energy level. So if we look at fluorine, its highest energy level is 2, okay? And there are 2 electrons in that s orbital, and there's 5 electrons in the p orbital. So just in that energy level of 2, there are 5, 6, 7 valence electrons. Those are the farthest ones out because they're in the highest energy level. And then if I look at chlorine, its highest energy level is 3, right? And there's 2 and 5 again, so 7 electrons. Are we seeing a pattern? 7 valence electrons. And then if I look at iodine, it goes up to 5. It skips down to 4 again, but its highest energy level is 5. And there are 2 here and 5 here. 7 valence electrons. They're just not all in the same energy level. But if we look at our periodic table, is right here. So we've got fluorine, chlorine, iodine, and bromine would follow that same pattern. In the same column, they're going to have the same number of valence electrons, just in different energy levels. And that will matter. That will tell us some information, but we can figure out valence electrons. Sometimes they'll have a lot of valence electrons, like they have 7, but if we're on the other side, they might only have 1 or 2. And that will matter too. That'll have to do with how they're going to react. That's what we're going to learn about today. So all atoms in a given column have the same number of valence electrons and similar chemical behavior. That's the takeaway there. So then we mentioned it before, these noble gases right here. They are noble because they have 8 valence electrons. And 8 is sort of like the magic number. When there are 8 valence electrons, that's called the ideal configuration. And that is like a satisfied atom. It's got all its electrons. It's happy, it's stable. It's not looking for electrons, it's not trying to get rid of them, and it's not trying to gain them. 8 is that magic number there. And so again, we call that the octet rule, when all the other elements are striving to gain that electron configuration that noble gases have. That's the octet rule, except for helium, because it's just different. Helium, lithium, and beryllium strive to have 2 valence electrons to be like helium, the noble gas helium, because they only occupy the 1s orbital. So that's why. So the beauty of the periodic table is that you don't have to figure out the electron configuration every time. We don't have to go through that every time we want to find out the valence electrons, which is great because we're going to use valence electrons to figure out how things combine together. And if we had to do the electron configuration every time, it would be kind of tedious. So that's nice, right? After you've been practicing that all last week. You do need to know how to do it, so don't forget how to do it. But we can just look at the number of the column that the atom resides in and figure out how many it has. So 1A through 8A have the same number. Remember I had you number your columns the other day. If you haven't done that, look at a periodic table and number it. You can have that information on there. So 1A, I could have just gave it to you all printed out, but I think sometimes it's kind of nice to add that yourself as you learn about it to kind of cement it in your brain. So 1A through 8A have the same number of valence electrons as the column number. And then 1B through 8B, that doesn't apply. So don't worry about that right now. So that's those ones through here. We don't care about those right this minute. But if you look, so this is column 1A, 2A. Let me skip over to 3A, 4A, 5A, 6A, 7A, 8A, which is the noble gases. So over here in 1A, it only has 1 valence electron. Over here in this 2A, it only has 2 valence electrons. And when I skip over to here to 3A, it has 3 valence electrons. And then 4, 5, 6, 7, and 8. Okay? So you can get that information from there. It's going to be a little more complicated than that, but that is something you can rely on. So now I thought I paused my video. So now we're going to learn about something called Lewis structures. I think I'm going to pause this. It just helps my videos to upload faster. So let me pause this and start a new one.